My fabulous chemistry faithful, video number 2. We are getting close to being done with nuclear already. Getting to the vocab. Isotope, big word. This is just like the picture is here. Isotope, remember we've done this before. Different mass, same element. So same number of protons have to have a different number of neutrons because as review, remember neutrons have mass, protons have mass. Okay? One or two or more atoms with the same number of protons but different masses. That different masses means different number of neutrons. Radioisotope, here we go. The radioisotope, as you can see in the picture, it's the end. A naturally or artificially produced radioactive isotope of an element. Radioactivity. Notice that those words are very close. You might want to figure out the difference and the nuances in the definition so you get them right on the quiz. The emission of radiation or particles caused by the spontaneous disintegration of an atomic nuclei. Some of the nucleuses are just so big that they're unstable, is really what that comes down to. So they become radioactive. Nuclear stability. Well, hey, how stable is said nucleus, right? The nucleus is stable, meaning it does not spontaneously emit any kind of radioactivity or radiation. A nuclide. This is also a product. Atomic species characterized by the contents of its nucleus and its protons and neutrons. The nuclide is basically just looking at the inside of the atom. Conservation of mass. This is a piece that's coming, and if you to you in like video 5 maybe or 4, but this is transmutations. So notice that the 238 up top for uranium is going to go into 4 and 234. Well, 234 backwards plus 4 equals 238, and 90 plus 2 equals 92. So therefore, I can figure out all the mass and atomic number for where those question marks are based on those other answers. It's going to be 91 and 234. And then if it's 91 and 234, I look up who 91 is. It's not going to be thallium. It's going to be the next one on the periodic table, in between thallium and uranium. Okay. Conservation of mass. Total atomic mass of reactants equals total atomic mass of products. Matter cannot be created or destroyed, simply rearranged. Natural transmutation. Here we go. Here's a natural transmutation. There's one reactant. It just naturally decays. It emits this electron and another element. When an element turns into a different element naturally, only one reactant. Okay. Artificial transmutation, there will be two, because I need to hit this uranium with a neutron, and the neutron is what's going to cut it. The fission. When an element turns into a different element with the help of another particle, hence two reactions. And fission and fusion would both have two reactants, because in fusion I take two elements and I put them together. Fission, I take one element, but I take a littler guy and I hit it with it and I cut it. So unstable, here's a fission, breaking apart. Neutrons released. It's going to go a little slow. Fission. Here comes the particle. That's why there's both of these guys have to be listed on the reactant side. And that particle is going to break this thing apart. Okay. The splitting of a heavy nucleus into a lighter nuclei. Fusion's the opposite. Take two lighter ones and put them together to make a bigger one. It's taking two deuteriums and making a tritium. Or a helium. The combining of nuclei to make a bigger and heavier nucleus. Alpha particle is one of the first emissions. Positive charged particle consisting of two protons and two neutrons. This is basically the nucleus of a helium atom. It has the least of the penetrating powers because it's so large. Helium nucleus is an alpha particle. Notice how those two things go together. You can't say that the alpha particle is an alpha particle on the vocab quiz, though. That just you gotta learn, you gotta know that. It can't just be the same word, but they are the same thing. A radioactive particle equivalent of to an electron is a beta particle. Okay, and then an electron is a beta particle. Positron. We don't see these a lot, but this is a positive electron. I have to review again one time how this actually works, but it's something that does happen. Protons are something we will count again. Positively charged element particle found in all atoms, and we know that the number of protons is the atomic number. Little review for atoms because we're so short on review time. Neutrons, also in the nucleus, have mass but no charge. Okay, no charge is key here. Gamma is the boogeyman. Gamma is pure energy radiation. Gamma, we are definitely getting hit with by the sun all the time. That's a for sure. The most penetrating radiation, neither the atomic number or the mass number has ever changed because it doesn't have any mass. Half life. This is how much time it takes for half of the stuff to decay. So, reading a chart like this is something that, guys, you need to be able to very intuitively be able to understand. If I have activity units, or it's generally grams on the left hand side, and I see it's 100, I know that at the half life, I will have 50 grams of it left. So when you go down to 50, you see the next X, and I can see that that's one half life. And at two half lives, I'll have 25, and in three, I'll have half of 25. Okay. The time it takes for half of the atoms to in a current sample to decay into something else. Radioactive decay, here's a bunch of them. Alpha, beta, gamma are the three main ones that we're going to deal with. Is the process by which the nucleus of an unstable atom loses energy by emitting radiation, including alpha, beta, and gamma rays and positrons. You can shorten that in your writing if you don't have a lot of space. Like it could say including alpha and beta particles, so you don't have to write particles twice. Little things like that, right? And last vocab done. Moving right along. 4 more videos and nuclear is done.